In this video, we're going to look at one population traditional hypothesis testing with sample mean. Hi, my name is Isabel, and I'm really excited to talk about one population hypothesis testing today. So what exactly do we need these for? Well, hypothesis tests help us determine whether or not there's sufficient evidence to support a claim that is being made. Our claim will then either be assigned to a null hypothesis or an alternate hypothesis. Whichever hypothesis we assign our claim to will directly affect how we interpret and word our conclusion. So let's take a look at an example and analyze it. The examples that I will be showing today deal with mean. In this example, we're going to be looking at data from a sample to make predictions about its population. After completing a minimum sample size calculation for the population, 90 women were randomly sampled through a systematic sample, asking about their GPA. Their mean GPA was 3.45 with a standard deviation of 0.33. Using the traditional hypothesis method, test the claim that women have a mean GPA greater than 3.15. I like to start these problems by pulling out all of the important information. That way, I don't need to keep referring back to an entire paragraph later on. In order to complete a hypothesis test, we're going to need to know the sample size, the mean, and the standard deviation. Because this was a conducted random sample, we know that we have a sample mean and a sample standard deviation. Since we do not know our population standard deviation, this is a t-distribution. For this particular problem, our n, or sample size, is 90, our sample mean is 3.45, and our sample standard deviation is 0.33. It's also helpful to pull out our claim. On the left is what our completed hypothesis test will look like. Splitting it up into these 4 steps makes it easier to work through. We will begin with step 1, assigning the claim. Assigning and identifying the claim is a very important part of the process. As I mentioned before, whether the claim is assigned to the null or the alternate hypothesis has a direct effect on how we word and interpret our conclusion. We will also need 2 bits of information from our list: the sample mean, and the population mean, which is from our claim. In regards to our problem, the null hypothesis, or H0, is set to equal the population mean. This is what we're trying to prove. So for us, it looks like this. The alternate hypothesis, or H1, will either be a greater than symbol or a less than symbol, and is also being compared to the population mean. It looks like this. We can see that our claim is not trying to prove that the population mean is equal to 3.15, so therefore, our claim is the alternate hypothesis, or H1. Now that we know what our claim is, we can move along to step 2, which is finding the critical values. In step 2, we will be dealing with finding the critical value, or values. Because our alternate hypothesis was a greater than symbol, we know that our graph will be right-tailed. Had it been a less than symbol, we would have been dealing with a left-tailed graph. And if the null hypothesis had been our claim, this would have led us to a two-tailed graph. For a t-distribution, we will need to use a table of critical t-values, or we can use a calculator to help us calculate this value. I will be using my TI-84 and its inverse t function, which looks like this. And it can be found by going to second, vars, and then for. We will be asked to input an area value and a df value. Our area value is the significance level, which for this problem is 0.05. To calculate the df, or degrees of freedom, we simply subtract 1 from our n value, so our df is 89. Once we input these 2 values, we hit enter to obtain our critical value. It's also very helpful to use a graph as a visual to help guide you through this. To do this, we will begin with a blank graph. Then we determine what tail it will have, which we already know is right-tailed. Then we shade in the area we need, and don't forget that the calculator will calculate the area in the left. So if we put in 0.05, this is the value in the right tail, and we will either need to flip the sign of our critical value or input the area to the left, which would be 0.95. I just like to flip the sign afterwards. Then, just like before, we enter all the information into our calculator and solve for the critical value. Once we have found our value, we can move on to step 3, which is calculating the appropriate test statistic. Since we're dealing with an unknown population mean, we use our t-test statistic formula and plug in all of our values, which looks like this. When we solve for t, we get 8.624 as our test statistic value. We then find where this would be on our critical value graph, mark it, and move on to step 4, the decision. Given our test statistic calculation, we now have to decide whether to reject or fail to reject H0. If our test statistic is in the critical region, we're going to be rejecting H0. If the test statistic is not in the critical region, however, we will fail to reject H0. Looking at our graph allows us to see that our test statistic is indeed in the critical region, and therefore we will reject H0. Now, all we have to do is step 5, the conclusion. Step 5, writing the conclusion. There are 4 possible ways to do this for hypothesis tests. 2 have already been ruled out since we know that our claim is the alternate hypothesis. Here is a visual showing the conclusion possibilities. Because the alternate hypothesis was our claim, and we ended up rejecting H0, we can use this one to help us write our conclusion. To finish up our hypothesis test, we can use all the information we found to say that there is sufficient evidence to support the claim that women have a mean GPA greater than 3.15. Now let's run through one more quick example to test the skills that we have learned. This time we will be looking at the mean GPA of men. In example 2, we are looking at the mean GPA of men, also taken from a systematic random sample of 90 men. Here is the hypothesis test as a whole. We begin by identifying the claim, which is the alternate hypothesis. Because there is a less than symbol, we know that it will be left-tailed. When we solve for our critical value in step 2, we get negative 1.66. Solving for our test statistic in step 3, we get negative 4.037. This is in the reject zone, making our decision for step 4 to be reject H0. Therefore, our conclusion is the same as our previous example. There is sufficient evidence to support the claim that men have a mean GPA less than 3.45. Thank you for viewing and considering my video.